Okay, we are on page 366, lesson 7-3. We're going to start with a square. Giving you a square, and the length of each side is 7. So tell me everything you know about this square. All the sides are 7. All the angles are 90. Okay. I'm going to draw the diagonal and ask you to find the length of the diagonal. How are you going to go about finding the length of the diagonal? Okay, a squared plus b squared equals c squared. What are a and b? 7 squared plus 7 squared is c squared. 49 plus 49 is c squared. So add them together and get 98 is c squared. Then you need to take the square root of each side. So c is equal to the square root of 98. 98 is not on the list of perfect squares, but does it have a factor that's on the list? And 2, so this is square roots of 2. Now I want you to tell me about the angles that were created when I drew the diagonal in. Okay. 45, 45, and then that one's 90. Okay, let's do another one. Next square, and each side of this square is 5. Tell me everything you know. Okay. All the angles are 90. We're going to do the same thing. We're going to draw in a diagonal. What do we know about the diagonal? Well, how are you going to find the length of it? Okay. So 5 squared plus 5 squared is c squared. 25 plus 25 is c squared. 50 is c squared. Take the square root. 5 square roots of 2. And my angles are 45 and 45. Any thoughts? Any comments? Think it's easy? Okay. So suppose that I give you this picture. What's the length of the diagonal? That's a square. And I've drawn in the diagonal. What's the length going to be? What'd you get, Carter? 13 square roots of 2. Is that what everybody got? Does anybody see a pattern? They're all going to have that square root of 2 in there, right? This is one of our special right triangles. So I want you to go back to the top, and I want you to title this page 45, 45, 90. This is a special right triangle at 45, 45, 90. And in that situation, let's talk about what those two 45-degree angles mean. Those two 45-degree angles at the bottom, they occur because the diagonal cuts those in half. It bisects. So we have congruent angles, And across from congruent angles, we have congruent sides. Of course, we've always started with a square, so we knew that was going to happen. But sometimes they're just going to throw you a triangle, and they're going to tell you that the sides are congruent. So you're going to need to automatically conclude that those angles are congruent. Okay? Now, when you find the length of the side, all you have to do to find the hypotenuse is take that value and multiply it by the square root of 2. Okay? So that's a 45, 45, 90. What are some of the problems you might see? They might give you this problem. They might draw a triangle and tell you that these are congruent and tell you that this is 8 and ask you to find the other two sides. Well, if you know that these are congruent and this is 90 degrees, then you know that this has to be 45 and this has to be 45. So what does this side have to be? And what does this have to be? 8 square roots of 2. They might give you this problem. They might tell you that that side is 12 square roots of 2 and that those are congruent, so what would the other two need to be? 12. They might give you this problem. Question? What's the matter? Who's confused?
Carter likes it, Latham hates it. I'm just trying to figure out what he's doing.
Latham, in a 45, 45, 90 triangle, the legs times the square root of 2 is the length of the hypotenuse.
Okay. I got it.
Okay?
I'm just curious.
What if I told you that this was 6? What would the other two sides be? How did they get that? Well, this is x and this is x, right? And all through these problems, we've been taking this value and multiplying it by the square root of 2 and coming up with that value, right? Yes? So what do we need to do now to undo that? Divide by the square root of 2. So x is equal to 6 over the square root of 2. Well, it's not 3. And it's also not okay to leave the square root of 2 on the bottom of a fraction. Who knows how to fix that? You got to multiply by 1. 1 could look like 7 over 7, 8 over 8, square root of 5 over square root of 5. But in this case, it needs to look like the square root of 2 over the square root of 2, because that way, when I multiply these together, I get the square root of 4, which I can take the answer of. And in the numerator, I get 6 square roots of 2. So one more step here is to simplify. So it's 6 square roots of 2 over 2, which is 3 square roots of 2. That's our final answer here. 3 square roots of 2. Okay? That's all 45, 45, 90. Everybody good on that? Okay. There's another type of triangle. It's called a 30, 60, 90. And we're going to start by looking at a triangle that's 8 on either side. What kind of triangle do we call one that's all the same size? The sides are all the same length. What's the word for that? Not isosceles. Isosceles is when two legs are the same length. I mean, this one fits isosceles, but there's a more specific word I'm looking for. Starts with an E. Equilateral. An equilateral triangle has 3 sides that are the same length. What do you know about the angles of an equilateral triangle? They're all the same. How big would that make them? $60. Okay. Now, if I were to cut this triangle in half, then the little angle at the top that was 60 is now how big? 30. And this angle is 90. And this 8 went for the whole thing, so how big is this piece? 4. You see the picture here, 30, 60, 90 is half of an equilateral triangle. Well, if you know that this side is 8 and this side is 4, can you find the missing side? Okay, now I'm going to write it up here that this is 8 and this is 4 and this is what we're looking for. So how would you go about doing that? Now tell me what A, B, and C are. Okay. Good. 16 plus B squared is 64. B squared is what? 48. So now I need to take the square root of that. Now what do you do when you take the square root of 48? What number from the list will go into 48? 4. If 4 goes in there, always check its squared partner, which is 16. Will 16 go in there? 16 will go in there how many times? 3. So this ends up being 4 square roots of 3. Okay? Now let's label this. This is the hypotenuse. It's across from the what? Right angles. This is the short side, or the short leg. And the short leg is across from the big angle or the small. I mean, I know it's not across from the biggest angle, but if 30 and 60, the short leg's across from the 30-degree angle. They partner up that way. And this is the long leg, and it's across from the 60. Okay? Now let's do another one of these and see if we can figure out a pattern. Okay. 11, 11, and 11. And so I know that this is 60 and this is 60, and you know that I'm going to cut that in half, and that's going to be 30. So once I cut that in half, instead of being 11, what's that at the bottom? 5.5. Okay, this might be a little bit trickier, okay, but this type of triangle is going to follow a pattern exactly like 45, 45, 90. Not the same pattern, but every 30, 60, 90 is going to have a same relationship among the lengths of the legs. So how am I going to go about finding this side right here? Okay, and I'm going to let 5.5 be A squared plus B squared equals 11 squared. What's 5.5 squared? 36.5?
30.25.
Okay. What's 11 squared?
129.
Okay. What next?
Subtract 30.25.
So what do we get? 90.75? Okay. Now, what do you think might happen? I mean, let's look so far and let's see what we can come up with. The hypotenuse is 8 and the short side was 4. What's the relationship there? Half. So if the hypotenuse is 11, the short side is 5.5, right? Same relationship? Yes. Okay. How about the long side? How's it connected in there? It's the short side times the square root of 3. So when I go to try to do something with this, do you think 3 will go in here? You know, this is probably going to break down into the square root of 3 and the square root of something else. How many times will 3 go into 90.75?
30.
And what's the answer to the square root of 30.25? So this is 5.5 times the square root of 3, which is the same relationship we had a while ago, right? Okay. Here are the two major things that you need to keep. I'm going to put them on the board in a little bit. We're going to do 30, 60, 90 since we just finished that. In a 30, 60, 90. Okay? This is the short side. How do you find the hypotenuse if you know the short side? Let's double it. How do you find the long side if you know the short side? Short side times what? Square root of 3. So let's put some numbers in here. Okay, this is 60, this is 30, this is 20. So I've given you 20, and 20 is the hypotenuse. So the short side is 10, not 10 cubed, 10 square roots of 3. Okay? Well, what about this? So that's 8 square roots of 3. Okay, good. My drawings are getting worse. The long side is 12. Short side times the square root of 3 is equal to 12, right? That's how we've been working these all along. So now what are you going to have to do? Divide by the square root of 3, and the short side is 12 over the square root of 3. But you can't leave it like that. You got to multiply by some version of 1 to rationalize that denominator. So this is 12 square roots of 3 over the square root of 9. 9 is 3, right? So this is 12 square roots of 3 over 3. The 12 and the 3 will simplify, and you'll get 4 square roots of 3. You still have to find this one. What are you going to do to find that one? Times 2, so that's going to be 8 square roots of 3. Those are the three situations that might occur. All right? Homework today. Page 369. 1 through 9, 12 through 20.